Welcome to EV Charging Stations, best practices for installation and troubleshooting, with a special focus on level 1 and level 2 charging stations. Thank you all for joining us. I'm Anthony, editor of Electrical Business Magazine and today's moderator. Please welcome our guest, product application specialist with Fluke, Mr. Sean Silvey. Sean, take it away.
Thank you, Anthony. Really appreciate the time and the opportunity to showcase really a revolving and changing world out there when it comes to electric vehicles and the charging stations associated with it. Again, I just want to introduce myself. My name is Sean Silvey. I am the product application specialist for Fluke products, basically supporting a plethora of products, whether it's the DMMs, clamp meters. We go into more even earth ground, and in this case, we're talking about electric vehicle charging stations. So let's go ahead and get started. We've got a great deck to get involved with here. You know, our agenda today, we're going to be talking about really the overview of what's happening in the network right now in North America. We're going to look and see what that looks like. We're going to look and see what the charging station infrastructure and system designs look like in that aspect. What does installation on operations and maintenance looks like? What we can do to emulate what that EV vehicle is doing on that type of system and what tests we can do. Some of those important measurements that we have to achieve. And then finally, what the landscape looks like. And again, as mentioned, feel free to raise your hand or put into the chat window, and we'll answer questions throughout and at the end as well. So really, this is taking off. Statistically, at the end of 2021, there were literally over 6,700 charging stations. And that's the public side of it. I mean, when we talk about people who are owning electric vehicles, there's literally 16,000 chargers out there in the market. Typically, these are called level 1 or level 2 type of charging stations. And we'll get into that as we move forward. There was a 39% increase just in the DC fast chargers alone in that aspect. So really, again, as you can see that the infrastructure is growing. There's more and more charging stations being installed out into our states. And on top of that, people are really adopting going into some type of EV vehicle, whether it's a hybrid EV or just a straight electric vehicle. Now, as you can see here in the US, by the end of 2021, there were over 130,000 chargers just on this level 1, level 2 infrastructure. That's not even including all the DC charging stations that are really moving across the country. Here in the US, there was a federal infrastructure bill that basically was $7.5 billion was allocated to the infrastructure for these EV charging stations. I heard statistically that some of the major automobile manufacturers, like GM, by 2035, I believe they said they will no longer manufacture a combustion gas engine. Every vehicle coming off their assembly line will be an electric vehicle of some nature. And we're talking not only, cars, but trucks, and even Tesla's now getting into some of the long haul trucking. So really people are adopting this and moving forward. So really, when we talk about this infrastructure and everything happening, there's a lot of players involved in this type of market. Whether it's the engineering and servicing team that's going to come out, they're going to identify on these fast DC stations what teams are involved, how to set this up. They're providing the software platform, because if you think about it, a lot of these fast DC charging stations will have a communication so we can pay for the charge while we're doing it. And there's going to be specialized tools and specialized technicians that need to be trained just to work on these fast DC charging stations. The EPC side of it, I mean, we can lay out and determine a site location what this looks like, and get all the players involved. We're talking about the utility and the electricians that are going to be going out and doing these installations. Well, once we get into that, there's a site construction aspect of it. We've got to do the actual installation of it. Maybe, yeah, obviously on some of these fast DC charges, we're going to have special transformers. Even out on site for the level 2 ones, we're going to have a transformer at least hooked up to have that 240-volt platform. And again, depending on what that looks like, they're going to have some type of computer interaction to be able to pay to have that vehicle charged during that time. Now, there are some sites that we've gone to where, like a hospital, the facilities of the hospital have given their employees the ability to charge for free. And so those do not take any kind of payment, but they still have that opportunity to do it, and they'll need to go out and hook their vehicle up and do at that point. But there are, because of these and because of this infrastructure, we do have some day-to-day operations like our charge point operator. They're responsible for going out and doing the day-to-day operations, determining if it's charging right. They're doing their testing on it as well. They're making their measurements on it. And then they have to certify it at the end. They have to, validate that it was installed correctly and it's working correctly. And that's the same with an O&M technician going out onto these fields. They're really heavily involved on the certification of it, making sure that it was installed correctly, whether they're troubleshooting the unit. The O&M technician is really truly an electrician that's been asked now to take on a new role in life to go out and now service and troubleshoot these charging stations. They were doing something completely different in their world, but now that we're moving forward on this, you've got to have a certified electrician to be able to do that. So they're typically, contracted by some type of CPO, and they are some certified electrician, whether it's a journeyman or something of that nature. They're even getting trained, depend on the charging station. They'll have specific training on that, and especially like the DC, the Tesla charging stations, they have to go through a program just to get that training and that charge. So let's take a look at what the EV charging, what that technology looks like. So right now, currently, really, you're going to see a lot of these level 1 and level 2 type of charging stations. They're all over. If you bought an electric vehicle for your residence, you could either go with a 110 volt, which is like a level 1 station, or you could go with that level 2 one, where it would be a 240 volt. Some of these are just plug and play. You can plug them into a 110, 120 outlet, hang it on the wall, and have it ready. So when you're done for the day, you can go in and charge it. There are limitations, though, to this type of charging station, and it's really the length of time it takes to charge a vehicle. Typically, these can be almost a 10-hour charge. So getting it home from work, plugging it in right away, and trying to go through that evening hours to get that vehicle charged back up. But these are really designed for that residential type of customer. Now, honestly, there's not much maintenance involved to this. You don't see any problems with them. Typically, they're a plug and play type of action. Now, once we start getting into that level 2 area to where we get into a commercial, it really changes the story. The prices increase in the product itself. And they are designed for sometimes private, but they're mainly for that public parking spaces. And just like I mentioned in my example with the hospital, they can go out and do that. Now, the voltage also too is a little bit different too, because it's a hardwired from some type of private building, whether it's in one of the utility ones, wherever they're setting it up in their landscape. A good example is some of these are putting into garages, like the structured garage for the hospital or some type of facility. Some of the malls are now taking this over as well, and they're designating parking spaces specifically for EV. They're able to get in and lay in the wires underground, the conductors, and get that all done. Typically, these are faster charging stations. They are 240 volt typically. And as you can see here, the kilowatt output is a lot higher, 19.2 kilowatts. Charging also too is a lot faster. You can typically get a good charge up to a full charge in 2 to 3 hours. So it's really great. You know, it's kind of the next step of building this infrastructure out, as we could see in our maps before, how people are now traveling with these electric vehicles. Before we had to say, hey, this is where my gas station is, and this is where I'm going to get my gas. Now we have to kind of map out, this is where my charging station is, what type of charging station, and how long is it going to take me to charge up as I'm potentially, traveling across country. Now, a little bit different here too, though. The installation of this product can be up into the high thousands. We're talking easily $10,000 per unit just to do this installation out. And this is where we start getting into more troubleshooting issues as well. Did they install it correctly? Is the line voltage correctly? Was it grounded correctly? Is the unit working even correctly on that? But as you can see, I mean, this market is growing, literally $8.8 billion on this level globally of what's happening just with these level 1 and level 2 charging stations. Now, once we move forward and get into the fast DC charge, that's definitely for commercial and public level. And they're the type of charging stations that are really set to do that quick charge. And they're not cheap. As you can see here in the slide, they can go between $20,000 and $50,000 just for the charging station alone. And they are designed for those, public areas. Some of them could be private areas as well, like a grocery store, in that aspect. But the voltage is definitely supplied directly from the grid. Yeah, Anthony, do you have a question?
Actually, it's more of someone seeking your opinion. Eric asks, when it comes to our gas stations, do you think they'll be changing over their fuel pumps over to electric charging just to stay in business?
That is a very good question. And I could see some gas stations doing that. But again, think about the scenario. We're able to pull up into a gas station, fill our gas tank up in about 10 minutes max. We've filled it up and out the door we go. Even with a fast DC charge, they need to have the infrastructure to be able to park a vehicle there and do a faster charge setup. Could they do that? They could. I think they're going to be playing with a lot of other players in this market who are also trying to grab that area. But again, some gas stations that I know of, you can barely get a pickup in there sometimes, a little long having to sit there with a vehicle and sit. But that's a really good question. It
Well,
would be kind of individual.
and one of our attendees, Mac, had I think his question had disappeared, but Mac was saying that to your point, a number of our gas stations don't have enough room and
They
enough
don't.
parking for those
Yeah.
vehicles.
And a lot of the gas station, the gas tanks themselves are literally underground and in that location. And so it's a struggle when even the gas truck comes in to just fill those back up. They take up a whole section of the gas station area just trying to get in and get out. Yeah, it's a little bit more difficult, but it is a great question. I guess it would really truly depend on the space allowed and if the company wants to go to that next level. Yeah, great questions. But and like we were just talking about with the DC charge, I mean, it could be charged up in less than an hour, but it's still going to take them time. Some of the places that I've seen these are at grocery stores where hey, you're probably going in for getting your groceries and stuff, and you're going to be there for at least 45 minutes, maybe 30 to 45 minutes. That potentially could charge up that station. The voltage increase too. I mean, these fast DC charges are going now to 480-volt, three-phase. They're charging at an incredible kilowatt to get those batteries charged up. The installation costs alone, as you can see, are very high. Could be $30,000 per unit just to put these into the site. So could that gas station actually handle that next level of infrastructure and be able to put this in? The troubleshooting and the maintenance is still the same. We still have to get out into the field and validate that nothing's happened with these systems, that they're still working correctly, they're communicating correctly. Every year, this one's ready to go. And again, you can see here, even on this level, a $2.2 billion. Yeah, Anthony.
Okay, so one of our attendees, Archie, is asking, so for level two commercial public chargers, to your knowledge, does the industry plan to allow for 277 480-volt single phase units? Archie feels that this will bring down installation cost and use less power. And as a follow-up, he indicates that this is for facilities that have 277 480-volt three/slash single phase systems.
So that would really go back to the charging station manufacturers. Now, as we move forward to that, if you think about it, these charging stations are already built on a pretty known grid structure. The 240 volt, the 120 volt, the three-phase 480 volt. So great question. It would really mean that if the charging station can handle that type of voltage, then yes, I would see them moving forward to putting it into those locations. Yeah, good question. So here's kind of a great design scope picture. There's a lot of imagery in this, and you can kind of work through because, when the factory makes this type of unit, it's calibrated and certified from the factory. We've identified, okay, where we're going to put it. So do we have the infrastructure to begin with to be able to put this system into play? Is there dedicated power, or maybe there's not dedicated power? We can put level 2 stations in on this. Maybe we can put the DC fast charge. So we need to put some type of step down transformer, something into play that has to take place for this type of system. Now, when we get into the metering aspect of it, this is another identifier is there's also the metering aspect from these DC fast charge. There's a metering aspect on your commercial, or residential and commercial. This is all being tied into somebody's power system. So let's talk residential first. If I installed a 120 volt system into this, well, it's being metered through my own electrical. That's pretty self-identified. It's gone through the transformer into my house at 240 volts split phase. I can plug this in, and I'm being metered pretty much personally on the use of what I'm doing at my house. I'm paying for it at that aspect, and I can charge that up in my own home. Same aspect on the side of the commercial aspect. Now it is going through a metering device. They still have to, can see what's being consumed on it. At this point here, that level 2 charging station potentially has a network. It's talking back whether it's given free, like in that hospital example, or you now have to pay for it. But you have to swipe your card, get the machine to work right, to then validate and get that charging aspect. And, but if you think about it, the maintenance aspect on it is pretty low. It's just going out and validating that it's working correctly. Now, again, on that DC high side, if you go down lower onto the screen, there's a lot more happening on this DC fast charge. They're going through rectifiers. We're going from AC to DC. There's a lot of switchgear involved. Some of these sites have to have a specific transformer installed just for this application. All of this going, back to that battery system. And there's even more intelligent DC, that network happening. With the Tesla charging stations, obviously there's accounts. We have to go in and sign up for these accounts. You're paying from a credit card or something of that nature. But again, it's all infrastructure and it's all communication. The infrastructure has to be there. Um, the maintenance has to be there on these sites. The commissioning and the installation aspect has to be there. Depending on the complexity of the unit, really validates the overall yearly, what's happening, annual, quarterly. Just depends on what's going on in that system. And you know, the charging stations advance themselves. If you think about it, a level one charging station typically doesn't have fans in it. It just has some, you know, the circuitry to change that AC to DC and charge that station. And the same with the level two type, even though our voltages have increased, we can still kind of get that. Not a lot of equipment inside that. Once we start getting into these fast DC charge, oh man, there's fans, liquid cooling systems happening within them because again, they're pumping out an incredible amount of energy to try to charge these vehicles very rapidly to get them out and get that going. So again, the fast DC charging stations, literally between 4 to 6 months, they're required to go out and do these inspections on it versus sometimes the level two and level ones, not necessarily, could be an annual maintenance. And I haven't heard with a level one in a house if they even do an annual inspection after that. It would be wise for them to set up some type of annual maintenance on it, just like you would with your HVAC system. Come out, change my filters, make sure I'm set to go for my heating and cooling, but also check my charging station, make sure that it's still up to speed like we were doing. So next, I want to kind of just show you some examples. Now, this is done in Washington State. Obviously, Fluke is out of Washington State. There's a Fred Meyer, which is a grocery store in the location. And they got some really great examples of what a level two charging station would look like. You can see from the aerial, and again, kind of back to that gas station scenario. These guys had the ability to segment a section of their parking area. They were able to put that together. They had to obviously break the concrete and then put these charging stations in location. They were actually able to use some of the transformers that were already on site because this was a 240 volt type of system. They were able to work through that. And then as you can see here, here's your typical charging station. Now, you know, and even on this one here, you can kind of see some of the nameplate. And that's going to be the key win on this. And basically back to that same question earlier about the different voltage levels, does the charging station be able to handle that interaction, that input and everything like that? So this is a great example because we see this a lot. Now, this is also the same example of your typical hospitals, some of your mall locations. They'll put some type of level two DC or level two charging station in that platform. Now, as we move forward, we start looking at like the Walmart Center here, another, you know, kind of resource. They designated a whole section of DC charging stations. They're out away from the building, but again, they isolated a spot in their location that we could do this. They had to put in now different types of transformers to be able to handle the amount of DC voltage up. What do we have here? 6 charging stations. If 6 cars all got in there at the same time, what that would look like to the grid and how it would handle that. So those transformers have to be able to handle that type of connection and load at that same time. But again, it's a nice little segue to go one looks like to now what this level 2 work looks like. So let's talk now level 1 and 2. So this is a great segue because really this is where some of the major recommendations are right now. There are a tremendous amount, as you can see in that one slide. It's almost triple of what the DC charging stations are. There's more level 1 and level 2 as customers are buying these products, buying electric vehicles. They're putting the charging stations in their home, or some of the facilities not necessarily can afford a DC charging station because of price point and some of the logistics of that. We can put in a level 2 one, still satisfy our customers, maybe our employees, and make that all happen. But all of these installations have to comply with a standard, the IEC 61851 and the IEC 60364. These are the maintenance procedures that are the standard on these types of stations. Now, again, this also too works with a type of plug. The handle itself is called a J1772 type of handle for those types of charging stations. But again, the test involved, they're going to have to make sure that it was grounded correctly. A customer can't go up and just touch the charging station and get shocked. That's all part of the installation safety of it. Was there any insulation breakdown in the wires? All of this has to take into account. Once we even get that vehicle there and connected to it, are the voltages correct? When they make that contact? So again, and also too, there's a communication aspect. If you think about a charging station, I take my vehicle over to it, and if my batteries are already halfway charged, is the charging station going to communicate to my vehicle and say, hey, give me the full amount? Or is it going to say, give me a slower amount of charge? All of that plays into this type of thing, all of that communication aspect in the voltage. Now, the next one on this is critical because we got to check the functionality of the vehicle. Once it's, or not the vehicle, I'm sorry, the charging station. Once that charging station is installed, how do we know how to check it? How do we can go in? The best way that they've done it in the past was to have an electric vehicle on site. They would disassemble the charging station, typically would take a couple of technicians there because of safety. They would bring an electric vehicle in, plug it in, and then run through their testing procedures. They would make sure that the voltage output was correctly, that everything was going there. Yeah, Anthony, we got a question.
There we go. I got to stop doing that when you're mid-sentence.
No, you're all good, man. I love it. I love the interaction. Please, everybody, keep bringing those questions. This is really going to take over the globe if you think about it. So it's really great that we're talking about it now.
No, it is great, and we've got a great conversational group here as well too, because there's lots of action in the chat as well. But before you go too far in your slide deck, one of our attendees is asking, what is and you may or may not know this, but what is the typical cost for the upgrades that you were talking about in the previous slide, or perhaps 2 slides ago, for those level 2 chargers in public? Because you were talking about transformers and some of the other things involved. Is that something you can speak to, or is that very project specific?
I think it would be very project specific. I mean, I think it's very easy if you think about going from a level 1 that you could plug into your house to a level 2. You would have to hire an electrician and pay for those parts, the conductors, everything to bring a level 2 charging station in. Think about the grid. I mean, you may, if a facility decided that they needed to bring in level 2 charging stations, I would think that, and I'm assuming, but I would think that they would have to do a load study in a location to make sure that that area could handle it. Would they need to actually set aside a different location, bring in the utility and electricians to bring in a step down transformer to just handle that location? Could you put in 1 or 2 stations in a spot, run it off of the existing system? Potentially, if the load was there and you could handle that. But if you put, say, 6 charging stations in a row, chances are that you would have to step that up. Now that could go, $15,000, depending on what that would look like for that transformer to be brought in, the man hours and the labor to hook it up, install it, whether it's underground and we have to trench systems out and dig that out, whether it potentially is overhead coming to the charging. A lot of that stuff is now put in the ground. So they're trenching it in, bringing it down the pole line, depending on what that looks like from the main grid, and then bringing it in. So price wise, I'm estimating, but you could, I mean, 5 digits easily. I mean, I could see that easily being in that arena just to bring that type of system in. But it would be, like you mentioned, Anthony, I think it's specific to the design and the application of where are they doing it.
Interesting. Okay, good. I am still not on mute. And you may get to this later in your presentation. So if you are, Sean, feel free to ignore this question for now. And I was waiting for this to occur. A question has come up about harmonics or other possible adverse impacts to power quality. Now, this is specific to the DC charger, so it may even be out of the scope of the level 1 and 2 that we're talking about here.
It is, but I mean, you're right. When we start connecting and doing a lot of these grid installations, voltage, dirty voltage, harmonics, transients, all of that plays into effect of these types of installations. Could there be harmonic problems coming back from the system? You bet. And that's where we would have to get some type of analyzer, some type of power quality analyzer, and look back on that aspect. I haven't seen too many DC. I'm still learning. Like I said, this is revolving, and man, I am definitely not the most expert on this. So but for what we've learned, I haven't seen too many DC harmonic problems. It's tied back into the AC side of that, causing that problem. So would you need to get a power quality unit, analyze that system, do a month-long record, make sure that vehicles are being plugged into that and charging? Do we have that type of problem? I mean, it's a great question. Obviously, the first person that would tell you would be the customer. I plugged this in, it's not charging. Your machine is not working. That then goes to that next level of getting a technician out there. Hey, this is not working. What's going on? They're going to start doing that investigation, hopefully, to then come to that conclusion. Let's hook up a power quality unit and actually analyze this type of system, see what's going on with it.
Hey, Sean, can you think of anyone who might be able to provide power quality analyzers?
Well, obviously Fluke. I mean, I'm going to throw it out there. Yeah, working for Fluke. Yeah, Fluke has a variety of great analyzers. If you're looking for it, somebody put in the chat a 1777 1777 power quality unit. Hands down, it's really changing the market, but that would be a great one to be able to go out and troubleshoot those systems, see if you have any transients leading into it, any harmonic problems. Thanks for the shout out, Anthony. Yeah, of course.
No problem, no problem. I just walked you right into that one. I've got another question here, and I find it very interesting because something that we've reported on regularly over the years, especially as the price of things have gone up. One of our attendees is asking, have you encountered or heard of issues with theft or vandalism of the actual charging cables?
I have not, but I could definitely see it happening. It's sadly, I could see the vandalism of them and stealing that. I guess you're playing with if the charging station had anything in it, you're cutting that. You could potentially have a major arc and a fault, and so people still copper all the time on other things. I just saw something about somebody stealing the backflow preventer from a community because of the copper and the brass. Awful. I mean, it's sad, but I have not seen that. I guess that would be the next statistical report of once these are really happening, how many of these are being, cut and stolen. I've seen a ton of Tesla charging stations out as I've drove across, different areas. Not a one of them been cut, but let's hopefully not give them the suggestion to do so.
Ri-
Exactly right.
Right. Fingers
Yeah.
crossed. Fingers
Fingers
crossed.
crossed. Yeah.
Now, one of our attendees, he's noticed that on your slide at the bottom there, you have EVSE, so supply equipment has a high rate of failure, estimated at 30 to 50%. So anyway, can you elaborate on that failure? And actually, before I go on, another attendee asks, what are the typical failure modes of or for electric vehicle supply equipment?
So great question. So the most of the common failures that I've seen have been either an unbalance of voltage. They didn't get the voltage hooked up correctly, which was also causing the issue. Some of it's also a communication piece. Again, if I've bought an electric vehicle, I would assume that everything in that electric vehicle is perfect. If I buy a charging station, the charging manufacturer is going to tell me that all of my chargers are working beautifully. We don't have any failures. It's the marriage and that communication piece that happens next, that did it really charge or did it not? Was that so? Communication errors are another big one. When I was out on site helping a customer with one of these, the vehicle was actually telling the charging station not to do something. There was an error. We were able to hook up one of our adapters, and we were able to validate that the charging station did its job and was able to do that. But that was the key thing. It was actually that communication piece from the vehicle saying, hey, no, I'm good. Don't do anything, which it wasn't right. So that was just one of those things. Now, when we come to failures, yeah, it's incredible the components that are inside some of these charging stations. They will fail, and that's it could be a voltage level issue. It could be an installation problem. One site that I went to, they actually installed charging stations. They never worked correctly. They even brought the manufacturer out. They still wouldn't work correctly. They ended up ripping out those two charging stations and putting in another manufacturer's charging station into the spot. Now, ironically, that was the same example about the communication piece. When we went out on site, we were able to identify that, yes, these new charging stations did work correctly. It was the communication back to the vehicle that caused the error. So again, this is so new. I mean, if you think about it, how many, I don't know how many people we have on, but how many of them actually own an electric vehicle? How many of them, obviously we're learning about it and we're knowing about it. And as this technology moves forward, I kind of think about that and back in the day with the hybrid vehicle. Man, when the hybrid vehicle came out, nobody wanted one, or it was really cool. Maybe somebody wanted it. The technology was so new, it had a lot of hiccups. And even as other car manufacturers tried to make a hybrid vehicle, they still had hiccups until they finally got it smoothed out over years of manufacturing, and people adopted that type of thinking of, hey, a hybrid vehicle's cool now to have. Let's buy a hybrid vehicle. It's the same feeling I get with the charging and electric vehicles. There's a push to do it. The technology's there. We're just running through the steps now and all the different failures that we're seeing. And, it was installation failure. Was it, wires, something of that nature. So there are a high amount of failures happening. It's just based on what that looks like. Different scenes, different, yeah.
Hey, Sean, or actually, I should say, Chehalis, our master in the background there. Sean was wondering how many people that we have on with us today are owners of electric vehicles. I don't want to put you on the spot, Chehalis, but is there any way to quickly throw up a poll that people can answer whether they're EV owners or not?
It's a good, and especially now that the gas prices are going up, people are adopting electric vehicles and hybrid vehicles even more, as we're moving for this. It's crazy. Well, let's move on while we get the slides going. And if you have any more questions, please, I know our time's kind of getting in that realm. But let's look at the electric vehicle, the installation aspect of it. So, when we have to come out and troubleshoot some of these level one and level two charging stations, if we do not have a vehicle, we've come up with an adapter to do that. Again, they're going to come out and try to connect to it. Um, if they don't have one, then they're trying to troubleshoot it without the vehicle, could turn into repeat service calls. And again, like we mentioned earlier, the EVs not being charged. Maybe there's not enough EVs for technicians. I don't know too many service companies that are sending out their technicians with an electric van to go out and then troubleshoot this. They may not have the right connections when they go out. And again, every one of these, there's so many manufacturers in the market for electric vehicle charging stations that they're different. Every EV is different. The vehicles are different. And there is a lack really of just solutions in this market to be able to handle this. So Fluke has actually come up with a very cool adapter. We don't need the electric vehicle now on scene. All we need to do is plug in our adapter, and that's going to allow us to do several tests on that level one and level two charging station. Uh, this is going to allow them to do a pre-check to make sure that it was grounded correctly. They can even do control pilot simulation to make sure that communication piece is working correctly. There are internally, and there should be in these charging stations, GFCI testing, ground fault testing, maybe a CP error, that communication piece, that we can simulate that there was an error and what does that charging station do. Um, this is an adapter that we do need to hook up to a DMM or potentially a scope meter. But once we get that connected, we can look at the voltage. We can look at the waveform of the voltage and the sine wave coming out of it. We can do loop impedance testing on it, resistance testing on it. Again, this is for electricians that are out there, and especially with these level twos and a lot of these commercial applications, they're able to go out and troubleshoot this type of system. It's for the outdoor use. And again, troubleshooting it, but also doing an operations and maintenance on it. You can do a certification now and validate that, yeah, the charging station is working correctly. And again, when we talk about pre-testing, we want to make sure that if a customer came out, a user, and they touched anything on that, it's not got any leakage current. That leakage, in none of that, it was installed correctly. This unit will allow them to test that prior to even hooking anything up. When the system's working correctly, there are GFCIs built into it. We can do a ground fault check. It'll actually trip out the charging station for a moment and then bring it back online again. The internals of the unit's working correctly. We can do a ground fault simulation on it as well. If there was actually a ground fault, what does the unit do? All of these are pre-checks to making sure that this was installed correctly and that the charging station's working correctly. We can do a CP error check on it. We can make sure that uh, if it lost even communication aspect, that's going to come on board. Again, we would want to use, yeah, go ahead.
Just a couple things before we get too far. So Chehalis kicked into high gear and quickly ran a poll for us to find out how many folks are actual electric vehicle owners who are
Yeah,
attending today. So it looks like we got people, a lot of people who need to do some shopping. We only got 10% ownership there.
And
Uh,
that's really, you're going to see that, Anthony. I think that's really where the market is right now. And a lot of people don't have electric vehicles. We're still reliant on the ways we do things in life right now. And some people are adopting it. And I can only imagine, I'd love to take the 10% of you, the 15 of you that answered that, and tell me all your woes later on, man. What are you dealing with? Because you've probably been on the forefront as the technology's going that direction. How did your charging station installation go in your house if you're doing it there? What's that look like for you out in the field? Have you been having be good later on to sometime have a sit down and a cup of coffee, and let's definitely talk about that. But good poll. Thank you, Chehalis, for doing that so quickly.
Now, one of our attendees is also asking, and it may be part of what you're discussing right now, but what Fluke solution is suggested for detecting whether the cause of the fault is coming from the electric vehicle and perhaps not the charger?
So that is a great question, because this is what this type of adapter does. This FEV 100 simulates being the vehicle. So we can run through and do all of these tests. We can validate that the voltage is working correctly. It acts as the electric vehicle. By using a scope meter, we can determine what the communication, like how much current the unit thinks it should be sending out. It's it's basically a CYA, and I hope everybody knows what that means, but it really is covering that the charging station is working correctly and that we have an issue with the vehicle. It then allows that customer to say, hey, maybe we need to get your vehicle in for servicing. Something's going on in that nature, because we can validate with this type of adapter that the charging station is working correctly.
And just looking at some other questions here, this is a sort of a crystal ball question that Robert is asking. But when it comes to the level 1 and 2 charging stations, um, what sort of stats or information do you have? How are they forecasted? How many are forecasted to be installed over, say, the next 10 years?
Oh, that's a good question. I think one of my slides, we had just what 177,000 of them right now, just in the market as we speak right now. And that's with the electric vehicles being out there, the level 1 and the level 2, with the infrastructure bill moving forward. That is a great question. Again, we're, going to this level 2 area. I can tell you that just in Washington state alone, they're going crazy on it. A lot of the malls, the supermarkets, everybody, um, even commercial, like going down to your business, they're now installing it because they know they have employees that are also, buying electric vehicles. I can see this doubling easily in the next 5 years, if not more. That's my own thinking, but it just makes sense if there's that much of a push in the all of North America. We have this structure bill being passed. People are adopting this more. I hate to say it, but gas prices right now are climbing and climbing. It does push people's thinking into going with hybrid vehicles and going with all electric vehicles. And hopefully the electric vehicle industry is getting better at their, I think that was one of the pushbacks that I've always heard with owning an electric vehicle. I don't get the distance like I do with my gas engine. So once that technology catches up again, if you can go 300 miles on one charge and it takes you only 1 hour to charge it up, well, that's like any time anyway. You drive 300 miles. Typically, you're going to stop and take a break, maybe even eat some lunch. Gives you that chance to step out and stretch your legs as you move on to that next leg of your adventure and moving forward. So, good question. Yeah, I wish I knew. It'd make
Well,
us all rich. I mean, I can tell you that we'd all know which direction to put our money and our capital in. I can tell you that.
exactly. Yeah, it is a bit of a crystal ball question, but with the way
Yeah.
government incentives are going, It's just going to keep growing. Now, I want to pass things over to Chehalis because she's going to activate someone who would like to ask you a question.
Perfect.
I just want to say that I tried to buy an electric vehicle, which would have been my second one, about 3 months ago. And after going to two dealers and not being able to get one for at least a year, and one dealer said that he wasn't willing to install the infrastructure, so he wouldn't be selling electric vehicles. I won't mention the manufacturer's name, but the bottom line was I was forced to buy a petrol fueled car because of the fact I had to have one immediately. So that's kind of a tragedy. The other thing is I have done calculations, and there's not enough generation if we were to take the total number of miles driven a year, multiply that by the average of 350 watts per mile on average, to power the 276 million vehicles that are driving, cars that are driving in the United States. That doesn't include commercial vehicles, which have a lot of application for electric vehicles, like school buses, garbage trucks, those kinds of things that have a lot of regenerative braking. So yeah, that's one of the big problems. You just can't get them right now.
Yeah, that is great input. And you're right. I mean, they're really reaching out to all of the utilities to try to see what that looks like. I know that there's more solar installations being installed just to try to help with the demand, all of that as well. But you nailed it. I mean, the infrastructure has to be base. It's almost it has to be a blend, and you're going to see that. I mean, that's a great shout out. That I mean, if you don't have it, how can you sell it? It just doesn't make any sense, even though the push is there to try to do it. So it really is going to be a blend as all of us move forward on this. What does this look like? And my final slide on this, really, what does that landscape look like? You kind of helped me finish off, my friend. That was a great one, because you're going to have it in all of these different aspects, whether it's in your own residential place, whether you're going down the highway, and like you mentioned, the highway transit system. They're all trying to move forward to this type of platform. They need to have the right tools to be able to do it. We've always been in the utility segment anyway, just with keeping, the safe tools that Fluke makes to help these guys out. But yeah, moving forward, I mean, you've got grounding that you're going to have to take care of. You got insulation testing and megging of the wires and the conductors if there was any faults. Power quality, man, going back to the original conversation earlier about power quality, you start demanding our system like that with the current infrastructure. If they can't build it, you're right, we're going to have some serious power quality failures happening. So all of that takes into play for this to run through. Well, I know we're getting really close to our time, Anthony. Just final slide for me is that give you some information on. So again, my name is Sean Silvey. I'm your product application specialist. Take a picture of my slide if you'd ever like to reach out to me, talk to me, or send me an email on anything like that. My product manager for the FEV units, her name is Alex Thompson. And there's her website as well, in case you ever need to reach out and contact us. Fluke is a very innovative organization. We make products because of the demand that's out in the field. This is a great example of this adapter. There was a need to be able to come out and test these charging stations. We quickly designed something and worked toward that, that aspect of it. Same when we talk about solar and some of the other areas that Fluke has always been a leader in, with electrical measurement and all that.
I'm just looking, we may have time for one more question. Now, a lot of you have been asking questions about the electric vehicle batteries themselves in terms of the impact that charging will have on those batteries. What does it do to battery life if you're charging with a level 1 and 2 versus a DC fast charger? Is that anything that you can speak to or have knowledge of, Sean, or do you think that would be outside of the scope of
Yeah,
today's discussion?
I mean, it's outside of this scope. I do know that if you think about it, you can sustain a battery through trickle charging capability. I've got a camper. I know what that looks like. Now, I can tell you I've depleted my camper battery because of heat, because of other issues, and we're going to see that in the electric vehicle platform. I mean, these batteries that definitely have to run through the test to do it. Do they have a way to test the batteries? Yes. I mean, obviously, a brand new battery coming out of the factory has been tested and certified. But once it starts going through this depletion process, recharge, obviously, they've already given a life cycle for the battery themselves before it would have to be replaced. Um, I don't know much on what the manufacturer and the battery type. Obviously, there are different battery types for the different vehicles. Lithium ion has always been a great one for this because they can dish out a lot of energy when they need to, and get that going. But yeah, good call out. I mean, again, like I said, this is really a changing market right now. So better batteries is going to be better in, better long distances, or potentially, I mean, look at the vehicles. If we tried to incorporate this in long haul trucking and what that would look like, and the battery banks to be able to handle the payloads of tons of material. Yeah, but again, it's all changing. What we say today, in a year from now, I bet you they come out with something new.
Exactly, and that is something that makes this discussion, electric vehicles and the way we charge them, it's timely, it's changing because of the technology keeps changing. It isn't, I don't think it's questionable technology, but I don't think we've reached market maturity for the technology.
Yeah.
It's still being pushed and advanced.
Okay.
So at least on the EV supply equipment, level 1 and level 2, at least we've got things figured out there to test them and, ensure that at least that part
Yeah,
of the equation is working
we've got
properly.
that. Yeah, we've got that right. And just like I said, with this type of adapter, you definitely want to use a DMM or a scope meter. We highly recommend a DMM that has like duty cycle, because that'll allow you to see the sine wave and see what the output is based on the duty cycle of the charging station. So, but yeah, great tools, a lot of stuff going on.
Sean, we've gone a few minutes
Yeah,
over, so I'm just going to wrap it up here. I apologize that we couldn't get to everyone's questions. There were some real good thinkers in there that I think would have made for a whole afternoon of discussion. But and so I apologize not being able to get to everyone, but I am pleased that we had a great, thoughtful, conversational bunch joining us today. With that, Sean, thank you for taking the
thank you.
time
Yeah, thank
and
you.
absorbing all those questions that were thrown at you.
Yeah, love it. I love the interaction. Again, thank you so much, everybody. I know whoever's out there still, thank you for attending and taking the time out of your day to hopefully learn something. Really hope we did.
Thank you all. Thanks for joining us.